Okay, guys, before we continue with other theorems, I want us to do a bit of exercise, like to solve some examples before we continue with other theorems. So today I'm going to solve two examples for you. Um, let's see how our theorems apply. The first question, example we want to solve says, find the value of the unknowns in the diagram, and we have that O is the center of the circle, and we have that the angle, this is A and this is B. The angle AOB is 100 degrees. So the unknowns we have here is Z. We also have another unknown Y, and we have another unknown X. Is that okay? These are the three unknowns. Now, I want you to see something that if I draw an imaginary chord, remember X and Y, Z and Y are angles of the same segment, right? Remember we did that before, angles of the same segment, and it is all angles subtended by the chord AB. You see, it's the same chord AB that sustains Z, same thing that sustained Y. So we know that Z is equal to Y, right? This we know that one first of all. Another thing we can know is that this same chord that sustains Z and Y at the circumference also sustains 100 at the center. And our very first theorem tells us that any angle we have at the center which is sustained at the same chord, what we have at the circumference should be what? Will be half of what we have at the center. It means that Z and Y will be both what? 50 degrees. That means Z is equal to Y and it's equal to 50 degrees. And we can put in bracket angle at the circumference is half the angle at center. That's just it. Is that okay? That's just it. So that's for Z and Y. Now we have another thing we are looking for, which is X. Now I want you to understand that this is not, see, don't be confused. This is not a cyclic quadrilateral because it doesn't touch the edge of the circle, right? It doesn't touch the edge of the circle, so it's not a cyclic quadrilateral. When it's a cyclic quadrilateral, it's like what we have here is a cyclic quadrilateral because all of them touch the circumference of the circle. But this one here, your point at the center is not a cyclic quadrilateral. So this plus this will not give you 180. Just know that this plus this will not give you 180. I mean, this thing came here. Okay, this plus this can give you 180. Y plus X will give you 180. Z plus X will give you 180 because they are opposite angles in a cyclic quadrilateral. But this one that is in the center, it will not give you 180 because it is not on the circumference. Is that okay? Okay, we'll see something that we'll see that it will give us. Definitely, anyhow you go about it, it will still give you, I think I've even spilled the answer. But we can also go about it another way. If this is 100 degrees, that means we have 260 degrees behind here, right? So this plus this will now give us 360, which is angle at a point, right? So this is 260, this is 100, making up to 360 degrees. So this angle 260, what does it sustain at the circumference? What is half of 260? It means that X is equal to 130 degrees. So you can do it like this, you get 130 degrees, it's still correct. Or you can say, if this is 50, opposite angles of a cyclic quadrilateral are supplementary, or they are equal to 180. So what plus 50, or you can just say 50 degrees plus X is equal to 180 degrees. That means X is equal to 180 degrees minus 50 degrees, which will give equal to 130 degrees. So anyhow you go about it, you get X to be 130. Anyhow you really go about it, you get your X to be equal to 130 degrees. Is that okay? That is quite simple to do. Now we move over to the second question. The second question says that A, B, C, D are points on a circle the diagonals of the quadrilateral AB. This is A, this is B, this is C, and this is D, right? Now we have that the diagonals, which is this is the diagonal, right? BD is diagonal for the two diagonals is AC and BD. Excuse me. And both of them meet at X, which is now we don't call it O, we call it X. It meets as X. Prove that the triangle ADX is this triangle ADX, this triangle, and BCX, this is another triangle, that they are both similar. How do we know that two triangles are similar? We say that two triangles are similar if they are, let me just put it this way, two triangles are similar if they have the same angles, or one is a perfect fraction of the other. Assuming that, what it means that if we have that this is 30 degrees, this is also 30 degrees, this is let's say 20 degrees, this is also 20 degrees, the three angles are all the same. Like this is a mirror of this. Is that okay? What we have here, we also have it here. We can say they are similar. Also, if we have something like this is like twice of this is twice of this, and twice of this, we can also say they are similar. Is that okay? So how can we prove that these angles are similar? Now I want you to take a note of something. This our chord AB sustains P here, and it also sustains Q here, right? This chord sustains P here, it also sustains Q here. It means that Q is equal to P, because it is the same chord that sustains them. So Q is equal to P. Is that okay? Now we also have that angle AXD is equal to angle BXC. Why? This angle and this angle are equal. Why? Because they are intersecting angle, right? Like when we have two lines intersect, the opposite sides of those intersects are equal. Is that okay? So whatever we have here, if two straight lines intersect, right, the two opposite sides of intersecting lines are always equal. So what we have here is what we have here. Also, what we have here is also what we have down here. So this angle at here and here are also equal. So we've gotten that Q and P are equal. We also gotten that this and this are equal. Now what we are left with is M and N. So if M and N are also equal, then the two angles are equal. But looking at it, you can still see that M and N are equal. Why? Because the two angles M and N are sustained by what? By DC. It is the same DC that sustains it. Is that okay? It is the same DC that sustains this angle. So we have that M and N are also equal. Even if you don't know for M and N, even if you don't know whether they are equal or not, so far these two are equal, then it's a must that M and N will be equal. Why? Because every angle in a triangle will sum up to be 180 degrees. So what we have, this plus M will give you 180. This plus N will also give you 180. So definitely M and N will be the same, because if these two are the same and all of them will sum up to 180, it means that this and this are also equal. Then we can conclude that ADX is the same thing as what? BCX, or they are equal to BCX. The two triangles are similar, rather. They are similar. Is that okay? So that is how we're going to end it for today. So tomorrow we'll continue from where we stopped. Ensure you do your assignment and invite your friends for tomorrow class. Have a nice day.